Hi, my name is Abiman, and today's date is March 29, 2022. And today's concept, I'll be talking about Wheatstone bridges. What is a Wheatstone bridge? Well, a Wheatstone bridge is a circuit, but more importantly, a method commonly used by engineers to measure minuscule changes in resistance with good accuracy. What is resistance, you may ask? It's basically a friction that opposes the flow of current. So a type of friction. And how does a Wheatstone bridge look like? Well, it is a circuit that has an electrical energy source from a power supply, and the circuit goes all the way to position A, let's just say, and it breaks off into two arms. And a Wheatstone bridge has two arms. Let's name this B, C. And then the arms conform to make a closed circuit, point D, and the circuit closes off back to the energy source on the negative side. So from point A to B, B to D, A to C, and C to D, there are resistors in the middle. Each respectively will name R1, 2, R3, and R4. This naming convention is important because the flow of current from R1 goes this way, so we'll name it I1. The flow of current from R2, which goes this way, name it I2. The flow of current from R3 goes this way, I3, and the flow of current from R4 goes this way, we'll name it I4. As you can see, R1 and R4, more importantly I1 and I4, have the same flow of current, and I2 and I3 have the same flow of current. Now, we measured the output of from point B to C to see if there's any resistance change in our circuit. And we usually measure this by output using either an ammeter or voltmeter. And a voltmeter looks something like this, with a dial that's pointing to the volt with connector pins attached to the circuit. And the formula we use to measure the voltage output, which is this, is equal to basically the voltage from B to C by multiplying the energy source EI with resistance R2 times R3, since they flow in the same direction for the currents, and R1 and R4 since they flow in the same direction, all over R1 plus R2 since the circuit goes this way and down, multiplied by R3 plus R4 since the circuit also goes this way and back up. And now if we pay attention, most importantly, to the top part of the circuit of the resistor, we could split them up into R2, R3, which is equal to R1, R4. And when both of these equal each other, we know that this subtraction will equal to 0. And anything divided by 0, or anything divided by 0 multiplied by 0 is equal to 0. And that's our V up, which will be 0. And this tells us that on this, imagine our circuit being on this beam, and our circuit is this rock, and the beams are balancing the circuit, tells us our bridge is balanced. And we want our bridge to be balanced because a balanced bridge is used to measure resistance change of resistive sensors, strain gauges, either using a null method or deflection method. And that's it for our lesson. Thank you.